Welcome back again, Centripetal Force Part C. Now, Part C mathematically requires a little bit of work ahead of time. Part A and B we've described. Part C, now we've talked about mass changing in Part A. We've talked about velocity changing in Part B, and now we're going to look at radius. However, what makes Part C a little bit tricky is the fact that if you want to change radius but keep velocity constant, we actually have to do some target times. Let me elaborate. So first off, if we want to find out the velocity for 100 grams, which was your first trial in Part A, we would figure out the entire change in distance divided by the change in time once around, and we could find out V. Now, since it's spinning at a constant rate, then we can use this equation. Now, I found the change in distance based on the circumference of a circle, in which we have 2 times pi times 1 meter, and that gets us a total distance of 6.28 meters. That's the same for everybody for Part A. Now, that 6.28 meters divided by a time, you may remember I talked about having the potential time of 9 seconds 10 times around. Well, how long does it take to go around once? Therefore, divide by 10. I get 0.9. If I divide 0.9 into 6.28, I get 6.98 or 7.0 meters per second with significant figures. Now, in Part C, we want to match this same 7 meters per second. But here's the tricky part of it all, is that what's going to happen is our radius is now changing, and therefore our distance is not the same. So we have to keep the same velocity with a different total distance once around. And so for Part C, we're going to have a radius of either 0.67 meters or 0.50 meters or 1.33 meters. And so we're going to use this same equation. However, now we're going to put our velocity that we want to keep constant of 7 and the change in distance related to the particular radius and calculate a target time that we're going to try to match when we carry out an experiment. Let me give you an example with, say, 0.5 meters. So with the 0.5 meters, with the 0.5 meters, I first off have to figure out change in distance by doing 2 times 0.50, 3.14 that is, times 0.5 meters, and that ends up getting me, well, 3.14. That's my total change in distance, right? So my total change in distance once around is 3.14. And then I need to do, well, my change in distance divided by my velocity is going to equal my change in time based on this original equation. And the change in distance I had to establish with my 0.5 meter radius or other radiuses if we were to go beyond that. And so now my change in distance will be 3.14. My velocity is the velocity from Part A. And I can do a division to figure out the time that I'm trying to figure out. And if I did 3.14 divided by 7, I end up with a time of 0.45. So this equals 0.45 seconds, whereas we're going to time it 10 times around, and so it would be moving the decimal once to the right, which is 4.5 seconds. So that means now, when you establish your setup, you're going to take your setup together, you're going to now move your tape. And your tape has to be moved, so now you have a radius of only 0.5 meters. And then you're going to spin your 0.5 meters, which is much shorter than the 1 meter, and you're going to hang an appropriate mass so that you can now get the target time of 4.5 seconds. Now realize, this calculation is based on an initial velocity of 7 meters per second that I established from a hypothetical time of 9 seconds. So the time that it took you to do your Part A with 100 grams is how this mathematics actually plays out for your lab group.